few days ago, news got out directly from the European Space Agency, and then we started again talking about ExoMars, and particularly about the successful deployment of the largest Mars parachute here on Earth. Well, the news is of some days ago, and this parachute were already been tested in 2021, and then they have been packed in their container for like 4 years. And the main reason behind this is the Russian invasion of Ukraine, and we'll talk about this later, talking about the countries involved in the development of this expedition, this technology. So first of all, we're talking about ExoMars. So as you may have thought, we're talking about Mars as a planet and a European mission on this planet. So today particularly we talk about the parachute system and the deployment. So what happened is a successful test of this technology. We're going to quote also the words of Luca Ferracina, who is the ESA ExoMars entry, descent and landing module system engineer. So it's the man behind most of the operations. So let's start basically. So you have to imagine a couple of parachutes. The first of the two is a huge, the second of the two is a huge one, 35 meters of diameter. So think about like a 10-story building in a diameter, and this is the dimension of the parachute. So it's quite huge, and you also have to think about that you have two of these. The first one is smaller, and you're going to see the deployment sequence, which is activated with the firing of the mortar, which let's say triggers the first pilot chute, which then inflates into the atmosphere and is then released, and the first main parachute, kind of 15 meters in diameter, is released and inflates. Now think about this. The speed at this stage are still super high. So the dimension of the parachute is not very high, but the strength of the lines and of the tissue and of the fabric of the chute must be very high, because one of the parameters of this operation was that the test operation was up above in the atmosphere, above the Antarctic continent, and the altitude was something like 29-30 kilometers, and temperature is not really a factor inside of this. What's important is the air density and the speed at which the mock-up of the capsule was traveling in the atmosphere. So very low density to simulate the low density of Martian atmosphere, and a very high speed, almost the speed of sound. This is critical to simulate the very high speed of the descent velocity when the capsule enters the atmosphere of the Martian planet and is slowed down by the atmosphere and the drag exerted by the atmosphere itself on the shield of the capsule. When the capsule is traveling slow enough, then the first parachute is released, triggered by a mortar, inflates, and then extracts the first parachute. So still the speed is very high at this point. So the first parachute is inflated, then it is carried away, and the second mortar firing inflates the second parachute and the second parachute and the second stage main parachute, which is the big brother of the couple. So they are working in tandem as a tandem sequence, as you may have as you may know. And the real importance why this test is so significant, because the speed is so high that deploying a normal parachute at such a high speed would destroy that parachute. So the study, the aerodynamic study behind of this must have been very precise. Every fold of the fabric inside of the container have been studied, and the whole model of inflation must have been studied. So this is critical also for this reason. The second parachute, well, under the second parachute, the capsule is probably flying very low, relatively speaking, to the previous speeds, so it's less critical. And you also have to think that this parachute have been, let's say, folded inside its container for like 4 years, so it's much longer than the traveling time from Earth to Mars. But for sure, scientists and engineers wanted to see if it was still working after all this time being, let's say, folded in its container. So the test was successful. Both of the deployment were successful. The capsule landed safely, and also at the first data that reached the scientists and the engineer were positive, and also by looking at the successful deployment with their eyes, they witnessed that the capsule landed safely and as expected on the ground. Now they are still analyzing the telemetry of the thing. They are still trying to understand all the parameters that they got from this operation. And well, think about this. You are traveling for like 6 months from Earth to Mars, and then your spacecraft starts to decelerate. And the only thing that can grant a safe and low enough landing on the planet are a couple of parachutes that are going to be deployed in a tandem sequence behind your back. Well, behind the back of your spacecraft. So, they're kind of important things. This success is important, and also the countries behind the thing: Italy, Netherlands, and Czech Republic, and also the companies like Thales Alenia Space are the, let's say, actor in play for this thing. I hope that also you enjoyed the success of this thing. If you're curious, subscribe or keep following the SpaceInfo Club. And as a last thing, we have released lots of courses. Most of them are free courses on our Learning Hub. So visit spaceinfo.club/learn to know more and stay involved, because a lot of content is going to come.